So it's fine to be able to print a hex to the screen, but that's not very readable by our human eyes, so let's see if we can print a integer representation to the screen instead. So similar to our hex to string output, we'll want to create a buffer char integer to string output of size 128. And we'll make this one a template class as well. Type name t, template function I should say. And then we want to return a constant char pointer integer to string, and we'll take in t value. To convert a integer to an ASCII representation, we need to divide it by 10 and use the remainder, and that remainder is our value that we need to display, if that makes sense. Alright, now first thing we need to do is we need to find the size of the string that we need to output. So we need to iterate through all of the values. So we'll declare uint8 size equals 0, and we'll create a uint64 size tester, which equals uint64 of our value. Just cast our value to 64, and then we'll do while size tester divided by 10 greater than 0, size tester divided by 10, increase size. So once this loop is finished, we'll have the size of our string that we need. Now we'll do similar to what we did before. We'll do index equals 0, and while value, which is the one we passed in, actually we'll cast this to a 64 uint64. So uint64 new value equals uint64 value. Now we'll do while new value divided by 10 is greater than 0. We'll calculate the remainder, so uint8 remainder equals new value modulo 10. Then we divide new value by 10. Then we can put into integer to string output our value. So size, which we calculated back here, minus our index, which we have here, equals the remainder, because the value we need is the remainder, and we'll plus 48 just so that we have the right ASCII value, and then we'll increment index. So that'll fill our buffer up with all of the characters that we need. Then we get to the very last value, and we need to print the last one. So uint8 remainder equals new value modulo 10, put in the last value, so size minus index equals remainder plus 48. Now we need to null terminate this string, so integer to string output size plus 1 equals 0, and then we can return integer to string output. Alright, so now let's test this out. So we've got all our keyboard handlers in here from the last video. I'll just go on and quickly move them into a new file just to clean things up. So keyboard.cpp, and we'll just extract all of this and replace it with include keyboard.cpp. And of course we need our pragma once, include type defs.cpp, and include text print.cpp. Right, so that's all working properly. We've got our main keyboard handler, so print string, integer to string, and we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll try that. I have a typo. Just make sure to have the D in remainder here. Alright. Now as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And we can change that to something like 5, 4, 3, 2, 1. And we have 5, 4, 3, 2, 1. Right. Now, what if we want to have a negative value, say negative 500? Let's see what that looks like. Oh, and that is not what we want. And that's because we need to actually convert this so that we can display it as a positive number, and we need to have the minus in front of it. So let's do that. So in here, we need to see if it's negative. So uint8 is negative equals 0, and if value is less than 0, so if it's negative, is negative equals 1, value times equal -1, which will create this, it'll turn this value into positive. And then we need to do integer to string output. 0 equals minus. Now we have the problem of this minus is going into the first slot, and when we do this, that's going into the first slot as well. So we just need to offset this. So is negative plus size minus index. And we'll do it with all of these as well. Right, so let's try that now. There we go, -500. And just to prove that positive still works, we have 500. Good. So now that we can print in a integer format, that'll be a lot easier for debugging numbers.